Alright, so in this video I'm going to go over a couple of the examples that we did in class, just to kind of reiterate and help you a little bit with each of these problems. I'll also mention something about each of the problems for you just to kind of help you out with some of your homework. So first of all, for our first figure we have a square, and with this square, if I complete my little triangle here for one of the congruent triangles that is formed by each of the radii, I really don't need the apothem for this problem because you will notice that these are both 45-degree angles. The reason why is because each of the angles of the square are 90, and this segment bisects that 90-degree angle. That's really just using the concepts of quadrilaterals that we did last semester. So this is a 45-45 triangle. I know that this radius is 11 and this radius is 11. And therefore, I can say that my side of a 45-45 is 11 root 2. And that is just knowing your relationship of a 45-45-90 triangle. That if I take the side and multiply by root 2, I'm going to get the hypotenuse. And now if I know that one side of my square is 11 root 2, I know that another side is also 11 root 2. In fact, all sides are 11 root 2. So in this case of a square, I really don't have to use my formula with the apothem and perimeter. I can go straight to just one side squared. And therefore, I'm going to plug in 11 root 2, and I'm going to square it. And that's going to be 11 root 2 times 11 root 2. And that will give me 121 times 2. 11 times 11 is 121. 2 times 2, root 2 times root 2 is 2. So therefore, 121 times 2 will give me 242. Okay? And that's going to, again, be in units squared. Now, number 2, we also did in class together, and this is a hexagon. And just remember that in a hexagon, the one single triangle that we talked about is going to be considered an equilateral triangle and an equal angular triangle. So I get all angles that are congruent. All sides are also congruent. So my radius and my side in a hexagon are actually the same. My radius is really only going to matter if that's all I'm given. In this case, I'm given a side, so that's not really going to matter that much. So now that I have the radius, I'm going to need to find the apothem. And remember that the apothem is the height of that one little triangle that is formed by a set of radii. Okay? So in this case, remember that this here is a 60-degree angle, and this is a 30-degree angle. So I have a 30, 60, 90 triangle. And I look across from the 30-degree angle to see if I have my short side. And I don't. Okay, well, I kind of don't. I do because I know that one side is 28, and I know that half of 28 is 14. So I kind of have it, but I do have to do a little bit of thinking in terms of what just that section is. Now in a 30-60, if I know the short leg, then in order to find my apothem, then I know all I have to do is multiply that 14 by root 3. So my apothem is going to be equal to 14 root 3. Now I can find my perimeter using one of my side lengths. I have 6 sides in a hexagon. Each side is 28. So I'm going to multiply 6 times 28, and I'm going to get 168. Now with all of that, I can now use my formula. Area equals 1/2 the apothem times the perimeter. So therefore 1/2 times 14 root 3 times 168. So when I simplify this, I'm going to take half of 14, which is 7, and then I'm going to multiply that by 168, and I'm going to get 1,176. And I don't have to do anything with root 3. I just bring it down, and that's going to be in units squared. Now in class, some of you did 4. So this is another hexagon. So let's take a look again to kind of reinforce. This is an equilateral triangle. Therefore, if the segment is 10, when I find my apothem, remember this was 10 right here. Half of 10, working backwards to find my short leg, is 5, and therefore my apothem that again is a special right triangle, 30, 60, 90. Okay? 10, work backwards, get to 5, go forwards to get to 5 root 3. Okay? So now that I have that, I know that one side is also 10 because an equilateral triangle, all sides are 10. It's the same as the radius. My radius is 10, and therefore my side is 10. My perimeter is going to be 6 times its side, so that's going to be 60. And again, I use my same formula, 1/2 the apothem times the perimeter. So 1/2 times the apothem times the perimeter. Half of 60 is 30. 30 times 5 is 150. Bring down the root 3, and that's a unit square. Okay? Let's take a look at a triangle. Okay? I think in class we did 7 together, so let's take a look at number 7. Okay, number 7 gives you the apothem as 2 root 3. If I complete my triangle, this is my 30-degree angle now, okay, because remember 60, 60, so half of it's 30, and 60, so half of it is 30. And that means that this is my 60-degree angle in my right triangle here. Okay, so if I'm given the apothem, which is 2 root 3, that's the short side of my right triangle. So to find a side, I'm going to do 2 root 3 times root 3. And that's again based on the concept of the 30-60 triangle. So that's 2 times 3, which is 6. Now that's just this one segment right here. I need the entire length. So I know this is also 6, and therefore one side is 12. One side is 12. My perimeter has 3 sides times 12, which is 36. Therefore, using my formula of 1/2 the apothem times the perimeter, I have 1/2 times 2 root 3 times 36. Half of 2 cancel, so therefore my answer is 36 root 3, and that's again a unit square. Okay? So let's take a look at some of these other problems. Let's go back. Looking at number 6 is 15, that's my radius. In this case, that is not a side length, so I'm going to have to work backwards to find the apothem. So if I work backwards, I divide that in half, so my apothem is 7.5. If this is 7.5, I'm going to multiply that by root 3, and I have 2 of them here for one side. So one single side is going to be 2 times 7.5, which is 15 root 3. Okay, and then you're going to again use that formula, 1/2 the apothem times the perimeter. In number 8, you're given the apothem, so you just have to work backwards, and you have to find a whole side. So when you work backwards, you're going to be finding this side here, but you're going to have to double it to find a side. Then find your perimeter using that side 6 times whatever you get for your side. And then use your formula 1/2 apothem times the perimeter. Number 10, you have a side length as 8 root 3, so don't forget to complete your triangle. Okay, find your apothem. 8 root 3, that means 1 is 4 root 3, and then, or 1, the short side here, which means that my apothem then is going to be times root 3. So 4 root 3 times root 3 because of the 30, 60, 90 triangle. So my apothem is 4 times 3, which is 12. Okay, and then you're going to use again your formula, 1/2 the apothem times the perimeter. Now on the back, I will tell you that number 13 is a little bit of a challenge, only because it has the radical fraction. So try it if you can, but it is a little bit of a challenging question. Okay? All right. So if you have any questions, please make sure that you see me either at lunch or in the mornings. And I'm actually not going to have this assignment due until